Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which I will review ratios and rates for your upcoming test. So let's first look at ratios. So a ratio is a comparison of two quantities that have the same units. You might be comparing like two sums of money or two distances or whatever. We'll see later in the video that rates compare two quantities with different units. For example, speed is a rate. It compares distance and time, which are measured in different units. So let's look more at ratios. So let's say in a school there is a ratio of boys to girls of 4:3. So we write this ratio 4 with colon 3. So because boys was written first, the first number in the ratio refers to boys, and girls was written second, so the second number in the ratio refers to girls. So this is a comparison of two quantities, number of boys, number of girls. You can think of each of these numbers in the ratio as a number of parts. So this school is like 4 parts boys and 3 parts girls. So in total, there are 7 parts. 4 of them are boys, so 4/7 of the school boys, 3/7 are girls. Another way to conceptualize this is for every 3 girls there are at the school, there are 4 boys. So note that this doesn't actually allow us to determine how many boys or girls are at the school. And that's because if you have a ratio like 4:3, if you times each number in the ratio by the same thing, the ratio stays the same. So 4:3, I could times both numbers in the ratio by 100. 400 to 300 is the same as 4:3. I could have times by a different number. I could times them both by 150. So 4 times 150, 3 times 150. I could have times them both by, 770. So if I times it by 770, I get 3,080 to 2,310. So in this school, there could be 400 boys, 300 girls, there could be 600 boys, 450 girls, and so on. We just don't know how many, because all of these ratios are equivalent ratios. So ratios are pretty much fractions anyway. Equivalent ratios work the same way as equivalent fractions. You know that a half is the same as like 5/10. And that's because in fraction, you can times the top and bottom by any number, and it doesn't change the value of the fraction, as long as what you do to the top, you do to the bottom. Same with ratios. As long as you do the same thing to every number in the ratio, then the ratio will still have the same value. So we're now going to look at writing some ratios. So in a class of 30, there are 20 boys and 10 girls, and what's the ratio of boys to girls? So remember, because boys is written first here, boys to girls, that number goes first in the ratio, and girls go second. So there are 20 boys to 10 girls. So this ratio is fine, but it's not simplified. We can simplify ratios just like we simplify fractions. So the way we simplify fractions is we divide each number, numerator and denominator, by the highest common factor. So the highest common factor, the highest number that goes into 20 and 10 is 10. So I can divide each number in the ratio by 10. As long as I do the same thing to each number in the ratio doesn't change its value. So 20 divided 10 is 2, 10 divided by 10 is 1. So the ratio of boys to girls simplified is 2:1. So say my team has won 12 matches, drawn 8, and lost 6. What is my win to draw to loss ratio? So win was written first, so that number goes first, then drawn written second, and loss third. 12 to 8 to 6. So that again can be simplified. Now ratios can have more than 2 numbers in them. You can compare more than 2 quantities as they do here. So when you're simplifying this ratio, you need to find the highest number that goes into all 3 numbers. So the highest number that goes into 12, 8, and 6 is 2. So I'm going to divide each number in the ratio by 2. So 12 divided by 2 is 6, 8 divided by 2 is 4, and 6 divided by 2 is 3. So my win to draw to loss ratio is 6 to 4 to 3. So when you're simplifying ratios, divide each number in the ratio by the highest common factor. Now, if there are only 2 numbers in the ratio, you can get your calculator to do this for you. So let's say I had to simplify the ratio 35 to 63. So in my calculator, I can't put the ratio, but I can put a fraction. So I can write in my calculator 35 over 63 equals, my calculator will simplify it for me. It'll tell me that it's 5 over 9. So I just convert that back to a ratio, 5 to 9. Okay, 35 to 63 is 5 to 9. So you can only use your calculator when there are 2 numbers in the ratio, not like this where there are 3 numbers. So make sure you know when you can and can't use your calculator. Make sure you know how to divide each number in the ratio by highest common factor. All right, let's look at dividing quantities in ratios and using ratios to find amounts. So what we're going to start with here is a quantity, perhaps a quantity of money, and we divide it in a ratio. So for example, we're going to look now at dividing, let's say, $1,200 in the ratio 7 to 5 to 3. So you always follow these steps. So the first thing is you find the total number of parts. I said each number in the ratio can be thought of as a number of parts. So I want to divide 1,200 into 7 plus 5 plus 3, which is 15 parts. The second step, I need to find the value of 1 part. So 15 parts equals 1,200. Each part, 1 part will be 1,200 over 15, which is 80. So each part is worth 80. Your final step is you multiply the value of 1 part by each number in the ratio. So I go 7 times 80, 5 times 80, 3 times 80. So note the numbers in the ratio, in your final answer, they should add up to the quantity you started with. So I know I've done something right because 560 plus 400 plus 240 does equal 1,200. It's as easy as that. That's how you do it. So let's look at finding other quantities using ratios. So let's say we have a ratio like this and we have to find x. So the key here is what you do to the first number in the ratio, you must do to the second number in the ratio. You must also do it to the third number in the ratio if it's there. So what have I done to get from 3 to 15? I have times by 5. So that means to the second number in the ratio, I need to times by 5. So x is just 8 times 5, which is 40. Because 3 to 8 is 15 to 40. So let's look at this ratio, finding x. So we're not going to do it any differently. So start at the one that doesn't have the pronumeral. So how do I get from 42 to 12? So I need to divide here, not times, because, 12 is a lot lower than 42. So you can't divide 42 by a whole number to get 12. So how on earth can you figure out what you divide by 42 to get 12? Well, all you do is on your calculator put 42 over 12, which is 3.5. So that means to get from 42 to 12, I need to divide by 3.5. So I need to do the same for the other number in the ratio. To go from 30 to x, I need to divide by 3.5. So if you put that on your calculator, x equals 30 divide 3.5, you don't get a whole number. So I'm just going to round it to 2 decimal places. Now, I did this on purpose because I want you to note the only time a ratio cannot have decimals is when you are asked to simplify. But if you're not asked to simplify, the ratio can absolutely have decimals, fractions, doesn't need to be a whole number. When it's not a whole number, you don't treat the ratios any differently. So let's look at a worded question involving this. So Andrew and James share their money in the ratio 4 to 5. Andrew receives $100. How much will James receive? So Let's have a look at how we would do this question, because it's actually very similar, almost identical to the ones we were just doing. So Andrew and James share their money in the ratio 4 to 5. Now, 4 refers to Andrew, because Andrew was written first. So 4 is Andrew, 5 is James. So we want that to equal, so Andrew gets 100, remember Andrew's first, and I want to find out how much James will receive. So I'll just call it X again. So now that we've set up this equation, we do it exactly the same way we've just been doing. So how do I get from first number to first number, 4 to 100? Well, I have to times by 25. So that means, get James's money, I need to times by 25. What you do to the first number in the ratio, you must do to the second. So X, which is James's money, is 25 times 5, or 125. So James will get 125, Andrew will get 100. How easy is that? Let's look at scales now. So when you use scales, that means you have a drawing that is in proportion to a real-life object. Think maps. Maps are a scale drawing. So everything is in the same proportion as in real life. So that means when you look at a map, if two cities are, say, further apart on the map, then they'll be further apart in real life. That's basically what it means in proportion. So the scales are a ratio. So for example, you might have a map such that 1 centimeter on the map represents, let's say, 10 kilometers in real life. So the way we want to conceptualize this is with a ratio. So we have 1 centimeter to 10 kilometers. Now, to write a ratio, though, the units need to be the same. So I'm going to change kilometers into centimeters. So 10 kilometers would be 10,000 meters. And if I want to go to centimeters, I times by 100. So 10 kilometers is actually 1,000,000 centimeters. And when you have a ratio where the units are the same, you can just drop the units. So the scale is 1 to 1,000,000. So if 1 centimeter on a map represents 10 kilometers in real life, the scale is 1 to 1,000,000. That means things in real life are 1,000,000 times larger than they are on the map. Now note that the first number of the ratio always refers to the drawing, and the second number refers to real life. So the second number is much bigger than the first. That means the real life object is much bigger than the drawing. So we call this number here 1,000,000 the scale factor. So scale factor of 1,000,000 means things in real life are 1,000,000 times larger than they are on the drawing. So that's how maps use scales. The scale factor is telling you how much larger things in real life are than on the map. We can write the scales as a ratio, but they need to be in the same units, both in centimeters, both in kilometers, or whatever. All right, we're now going to take a look at rates. So we're now going to look at rates. So as I said before, rates compare quantities with different units. So to give you an example of a rate that's really important to me and probably really important to your parents, the cost of petrol. It's certain number of cents per litre, so we're comparing different quantities. So let's say, for example, that I buy 60 litres of petrol, and let's say it costs me $81. I wish it only cost that at the moment. So we can write this as a rate. So I might want to do cents per litre. So I want money per litre. So I have to go money. Now this slash here means per, you say it, but also means divide. So I go $81 divided by 60 litres. So 81 divided by 60 gives me 1.35. So that means petrol is $1.35 a litre, or 135 cents per litre. So this is a rate telling me how much money I pay per litre. So sometimes it can be tricky to know which number you divide by which, so you have to look at what your final answer will look like. In this case, I wanted my answer to look like cents per litre, so I divided money by litres. Let's look at another example. So let's say I've travelled 100 metres in 10 seconds and I want to write this as a rate. Do I divide 100 by 10 or 10 by 100? So the rate I'm looking for here is speed, distance over time. So usually this would be written as like number of meters per second. That's speed, distance over time. Sometimes you'll see speed in kilometers per hour, but meters per second is still a speed. So because I want meters per second, and this line here means divide, I do the number of meters divided by the number of seconds. So 100 divided by 10 is 10. So if I travel 100 meters in 10 seconds, my average speed is 10 meters per second. So this is the average speed. So what it's saying is on average each second I go 10 meters. This here means on average I pay $1.35 for each litre. Okay, so that's what rates are. They're just averages of something per something. So that's what rates are. I'm now going to do a little more on speed. So you may have seen this triangle for speed before, maybe in your science classes. So you have D, which means distance, and you have S and T that tells you how to find it. So what it means is that speed equals distance over time. If you want to find the distance, you can see that on the bottom you have speed times time. If you want to find the time, it's distance over speed. We're going to be using these in our calculations. So let's look at this question first. Travel 220 kilometers in 30 minutes. What is my average speed in kilometers per hour? So because I'm looking for kilometers per hour, I need to divide the number of kilometers by the number of hours. But hang on a minute, 30 minutes isn't an hour. So 30 minutes is actually half an hour. If you don't know how to convert minutes into a fraction of an hour, you divide by 60. So 30 minutes is 30 over 60, which is 1/2 of an hour. So what's my speed in kilometers per hour? So speed equals distance over time. So it would be 220 divided by 0.5, which is 440 kilometers per hour. So maybe you're in like a train or something like that. So how far would I travel in 3 hours? So notice 440 kilometers per hour is saying on average I travel 440 kilometers in 1 hour. So in 3 hours I would travel 440 times 3. 3 lots of 440, which is 1,320 kilometers. So how far would I travel in 4 hours and 45 minutes? So again, it's asking for distance as the previous one was. So what I do is I use my formula, distance equals speed times time. So it's going to be speed times time. But hang on, how many hours is 4 hours and 45 minutes? You can't do 4.45. That's wrong, because 45 minutes is not 0.45 of an hour. 0.45 of an hour is 27 minutes. So what you do, go to your calculator. 45 minutes is 45/60ths of an hour. Your calculator simplifies it to 3/4. 45 minutes is 3/4 of an hour. 3/4 is, of course, 0.75. So I need to times 440 by 4.75. And that gives me 2,090 kilometers. So that's how far I would travel in 4 hours and 45 minutes on this very fast train. Let's look at a question involving finding the time. So let's look at this question here. How long would it take me to travel from Canberra to Perth at this speed if the distance between the cities is 3,600 kilometres? So we are finding the time, so it's distance over speed. Now you've just got to make sure the distance and the speed are in the same units. Here they are. The distance is in kilometres, but the speed is in kilometres per hour. So I can do the simple division 3,600 divided by 440, which was the speed in kilometers per hour. Now, the answer I get is about 8.181818. It goes on forever. So 2 decimal places, it's 8.18. So that means 8.18 hours because the speed was kilometers per hour. If it was kilometers per minute, the answer would be in minutes. So it's going to take me 8.18 hours, but how many minutes is 0.18 of an hour? So if you just went to your calculator, 0.18 times 60, you get 10.8, close to about 11 minutes. So that is about 8 hours and 11 minutes, okay? Because 0.18 of an hour is 0.18 times 60, about 11 minutes. All right, we're just going to look now quickly at the unitary method. So the unitary method is actually very similar to what we did when we were dividing quantities into ratios. What we do is we find the value of 1 unit and then we end up multiplying. So very similar to what we did when we're dividing quantities into ratio. We find the value of 1 part and then multiplied. Let's look at some questions that require the unitary method. So 3 kilos of lollies cost $13.50. How many would 7 kilos cost at this rate? So what we do is we find the value of 1 unit. In this case, we're going to find what is the cost of 1 kilo of lollies, and then we just times that by 7 to get 7 kilos. So if 3 kilos costs $13.50, 1 kilo will cost $13.50 divided by 3. In other words, we're finding the cost per kilo. So that means $13.50 divided by 3 is $4.50. We're paying $4.50 for 1 kilo or $4.50 per kilo. So 7 kilos will cost just $4.50 times 7, which is $31.50. Let's do one more type of question like that. So let's say I can run 100 meters in 12.5 seconds. How far could I run in 5 minutes at the same speed? So I'm going to find out how far I could run in 1 second. In other words, I'm going to find how many meters per second I can run. So I go 100 divided by 12.5, which is 8. So it's 8 meters per second. I can travel 8 meters in 1 second. So 5 minutes is 300 seconds. So in 5 minutes, I would travel 300 times 8, which is 2,400 meters, or if you like, 2.4 kilometers. How easy is that? I'm now just going to do a couple of challenge questions for you. So, the angles inside a triangle are in the ratio 3 to 4 to 5. What is the size of each angle? So, the angles in any triangle add up to 180. So, in this question, we're being asked to divide 180 in the ratio 3 to 4 to 5. And we're going to do it exactly like we did in the previous example in this video. So, 3 plus 4 plus 5 equals 12. So, there are 12 parts. Each part, or one part, is worth 180 over 12, which is 15. Now we times each number in the ratio by 15. So 3 times 15, 4 times 15, and 5 times 15. Again, these 3 numbers should add up to the quantity I started with. And they do, so I know I've done something right. Let's look at another question. So the perimeter of a rectangle is 40 centimeters. Length to width ratio is 3 to 2. What is the area? So note, if you have a rectangle and the perimeter is 40, then the 2 dimensions, the length and the width, they must add up to 20. Because when you double it, you get 40. All 4 sides add to 40. So now we're being asked to divide 20 in the ratio 3 to 2. So again, 3 plus 2 equals 5. There are 5 parts. Each part is worth 20 over 5, which is 4. Then I multiply each number in the ratio by 4. So 3 by 4, 2 by 4. So the dimensions of the rectangle, the length is 12, the width is 8, therefore the area is just 12 times 8, which is 96, because the perimeter was centimeters. This will be centimeters squared. How easy is that? Let's do one involving speed. So let's do this question. I drive to work at 80 kilometres an hour. It takes me 6 minutes. I then cycle home at 25 kilometres an hour, and I'm going to figure out how long it'll take me to cycle and what will be my average speed. So firstly, if I want to figure out how long it will take me to ride home, I'm looking for the time. Time equals distance over speed. I first need to find the distance. I already know the speed, 25 kilometers per hour. I need to find the distance. So what is the distance to work? So if it takes me 6 minutes at 80 kilometers per hour, I'm going to first find the distance by using distance equals speed times time. So the speed is 80 kilometers per hour. So you're probably tempted to just times by 6, but I can't do that because the speed is per hour and the time is minutes. So I need to change this minutes into hours, and I divide by 60. 6 minutes is 6/60ths, or 1/10 of an hour. So if I put that on my calculator, I get 8. So the distance is 8 kilometers. So how long will it take me to cycle 8 kilometers at 25 kilometers an hour? So the time will just be distance over speed. If you put that on your calculator, you get 0.32. So you're probably thinking to yourself, well, what the hell does that actually mean? Well, remember the 8 was kilometers and the 25 was kilometers per hour. So this is 0.32 hours. So to find out how many minutes that is, you go 0.32 times 60, which is 19.2 minutes, or 19 minutes and 12 seconds. So that is how long it will take me, 19 minutes and 12 seconds. Okay, if you don't know what 0.2 of an hour is, you just go 0.2 times 60 equals 12. So 19 minutes and 12 seconds, that's the first part of the question. So what will be my average speed? Well, you might be tempted to think, okay, I'm going the same distance at 80 kilometers an hour and 25. I just take the average, add them up and divide by 2. Now that doesn't work. The reason it doesn't work is because I'm going to spend more time traveling at this speed than this speed here. So my average speed is going to be closer to 25 kilometers an hour than 80 kilometers an hour because I spend more time cycling. So that's the first part of the question. The second part of the question, which I'll do in black, I want to find average speed. So speed equals distance over time. So I figured out that the distance to work is 8 kilometers. So the total distance there and back will be 8 times 2, which is 16 kilometers. Now, I figured out I'm 6 minutes driving, 19 minutes and 12 seconds is spent cycling. So total is 25.2 minutes, or 25 minutes and 12 seconds. But remember, the distance was kilometers and this was minutes. So when I do 16 divided by 25.2 in my calculator, I get a weird number. I get 0.635 approximately. So that's kilometers per minute. So if I want to change that to kilometers per hour, so this is saying I go 0.635 kilometers in 1 minute. How far would I go in an hour? I would just times that by 60. So I get about 38.1 kilometers per hour. So go from minutes to hours there. I times by 60 because if I go 0.635 kilometers in 1 minute, I'll go 60 times that distance in 1 hour, and this is my final answer. So note it's closer to 25 than to 80 because, again, I spent much more time cycling than I did driving. So this was a hard question. Please come and see me if you want me to explain it any further. Other than that, best of luck studying for your test. This has been the luckiest maths teacher in the world. Have a great day.